and I'm going to get this party started. I am one of Laura's two advisors. Steve Luby will also say a few words. I wanted to be sure to thank Nicole Ardoin, who is the chair of Laura's committee, and I assume that she will have lots of other thank yous, so I'll leave it there. So the plan for today is that Laura will share her work with us for about 45 minutes, then we'll have about 15 minutes for Q&A, and Laura will just let you run it yourself. After which we are going to scoop her up and run away. So we know you will all want to stay and mingle with her, but we will be proceeding back to Y2E2 for some additional conversations. So we just wanted to warn you that there won't be a lot of chit-chat after that. In thinking about introducing Laura today, I thought, I wonder what my first notes about her are in my file that I have on each of my advisees. And I think it will surprise no one here that the first time I met Laura, the notes I made were research interests seem potentially aligned with water health and development. High intensity. Nailed it. And that's it, right? You know, you start thinking about Laura, and that really characterizes the way that she engages with almost everything, right? So she is intensely engaged, both in her scholarship and her research, and in this community, but also out in the world, right? So not sure entirely where she finds the hours to do it, but there's always one more thing in which I hear that Laura is engaged, right? And I think collectively, we all know most things about Laura, but each of us would be surprised about other things that we know, that others know that she's been doing. So intensely engaged, intensely curious, which at times can be a little challenging, reining Laura back from lots of the new ideas that she has, and intensely communitarian. You know, really somebody who believes in community, is willing to put in the time to help build it. And I think the fact that we have such a large crowd here is a testament to the fact that takes root everywhere she touches down, right? So she is an integral part of lots of different communities here at Stanford. And all of these are a tribute to her intensity. I'll hand it over to Steve Luby.
When I came to Stanford, I was trying to figure out how do I work on this campus, who are my graduate students going to be, a lot of people coming to the door, how do I settle this out? And one of the ways that Laura very early on distinguished herself, she said, oh, there's a chance to work in Bangladesh? I'd like to work in Bangladesh. So she applied for a Boren scholarship. She won it. And really, just like what Jenna was saying, Laura was enthusiastic. She was enthusiastic to learn Bengali. She was enthusiastic to insert herself for a year in Bangladesh and understand that context. She was enthusiastic about all things having to do with WASH benefits, Bangladesh, this big trial we were doing, and enthusiastic about saying, you should think more about exposure. There's a bunch of exposure questions here. So I really appreciated her enthusiasm. I've also really appreciated her generosity. She has been very generous with her time in terms of connecting with the broader team in Bangladesh and really working to develop, to include them and to develop their skills. And I think we've all had this experience of generosity that she has brought to the group. And so as a result, when Laura joins the group, the whole group is lifted. So I'm glad that everybody's come here, and I think we're really interested to listen to what this creative, enthusiastic, intelligent young scholar has done. So.
Thanks for that introduction, Steve and Jenna. And thank everyone for coming. I've been looking forward to this day, and I'm just so excited to have so many people here. It's really heartwarming. So today I'll share with you just a sliver of something that I've been working on in the last 6 years. As Jenna and Steve has mentioned, I've done quite a few things, ranging from container-based sanitation in Bangladesh, Kenya, and Peru, to looking for helminths in soil and working on improved flooring, also working on child development and hand washing in schools in China, and recently working on ventilation in both Mongolia and Bangladesh. And the thread that ties all of these things together is a focus on child health and reducing child deaths. So today I'll tell you about my work on the second leading cause of child death among children under 5, diarrhea. This is the cholera tent outside the International Center for Diarrheal Disease Research in Bangladesh, which is my partner in Bangladesh. And cholera tents are put up to handle the overwhelming number of people that come in with life-threatening diarrhea every year. Diarrhea causes 500,000 deaths worldwide in 2015, and while that number has dropped by 30% since 1990, there's still high rates of diarrheal disease that's non-fatal. So fecal matter can contain pathogens such as Campylobacter, Campylobacter, Giardia, and norovirus, and these can cause diarrhea. Fecal matter of warm blood mammals also contains E. coli and Bacteroidetes, and these are used as indicators of fecal contamination. While they're not pathogenic on their own, E. coli and Bacteroidetes in a malnourished gut may result in a condition called enteric enteropathy. And both of these, diarrhea and environmental enteropathy, can lead to malnutrition or exacerbate malnutrition. So while fecal matter may or may not have pathogens, we're still concerned about it because it can have adverse child health outcomes. There are many ways that fecal matter can get from the environment into a child. It can go through fluids, such as drinking water, through flies and into food, through soil that is directly ingested or may contaminate food, onto hands that are put into the mouth, and through objects that children may also put into their mouths. This diagram, called the F diagram, is a common way to visualize fecal transmission. There are different mechanisms by which we can interrupt each of these pathways. So, for example, research in the field of water, sanitation, and hygiene, WASH, has shown that sanitation interventions can reduce diarrhea by 25%. Drinking water treatment can reduce diarrhea by 40%, and hand washing interventions have been shown to reduce diarrhea by 30%. Food hygiene is less well understood, but one study showed that teaching mothers food safety practices reduced diarrhea by 52%, and there's only been one study on clean floors, but they also have the potential to reduce diarrhea, and the study in Mexico showed a 13% reduction in diarrhea. So bringing this back to the WASH benefit study that Steve mentioned, this was a study of water, sanitation, and hygiene interventions in Bangladesh, in South Asia. There were over 5,000 households involved in multiple arms of the study. And the study really focused on sanitation, dual pit latrines, water treatment and safe storage, as well as hand washing, sort of based on the theories that those are the primary pathways by which children ingest fecal matter and can get diarrhea and have stunted growth. So based on the results of this, we see that the interventions of sanitation and hand washing reduced diarrhea by 40%. We did not see a significant effect in the drinking water treatment arm, but 40% in these two arms is still a substantial reduction in diarrhea. But you might wonder why it wasn't 100%, right? Did the interventions incompletely address their target pathway, or are there other pathways by which children are still getting exposed to fecal contamination? So the question of which pathway contributes most to children's ingestion of fecal matter came to my mind the very first time I saw this diagram, I think probably my second day at Stanford. And I asked experts in the field, so which of these is the most important? Which one should we focus on? And to my surprise, neither experts nor the literature could really answer that question. And identifying these pathways and which contributes the most to children's ingestion of fecal matter is important so we can prioritize our interventions. Unfortunately, we don't have endless money, especially in WASH, and so it's important to think about which interventions you really want to sink your time and effort into to get the big spend for your buck in improving child health. So, if the pathways are drinking water, if the pathways are drinking water or children putting their hands in their mouth, you might want to focus on drinking water treatment and hand washing. But if the pathways are food consumption and direct ingestion of soil, then maybe it would be more effective to focus on food hygiene and clean floors. this was really the underlying motivation for all of the work that I've done in this space, is trying to understand which pathway of fecal transmission contributes most to children's ingestion in rural Bangladesh specifically. So, a lot of people have looked at this topic of pathways by looking specifically at the contaminant concentration, right? So they'll go out and they'll measure many different environmental reservoirs and compare the concentration levels. How much E. coli do they find? How much fecal matter do they find in those sources? But that doesn't give you a full picture of what is getting into the child, right? We're interested in fecal-oral diseases, and so we're getting more and more information about the fecal side, what's in the environment, but we didn't have a lot of information on the oral side. How is it getting into the child? And so that's really where I tried to focus. So I looked at exposure factors, which is looking at children's contact with the environment. What are they putting into their mouth and how often? And that's covered in, and then we also looked at transfer efficiencies. So how much of the contamination in the environment is actually going into their bodies when they put something into their mouth, right? And I addressed exposure factors in my first 2 chapters, and I combine all of this information and look at dose in my 3rd and 4th chapter. So I'll keep this equation as a roadmap, and I'll put it at the top of the screen so you can follow sort of where we're at in this, looking at exposures, transfers, contaminant, and dose. So thinking about situating ourselves in the literature, there's been not very much attention to exposure of children to fecal contamination historically in the field of water sanitation and hygiene. There was one study in Peru in 1990, which looks at children's putting things contaminated with fecal matter into their mouths, but then there was a long break, and there only recently has been renewed interest in this, with studies starting to be published in 2013. And my work was really at the start of this renewed interest in exposure. Given that there hasn't been a lot of data on exposure for these children in low-income settings, there also isn't a lot of literature on the dose that children might be ingesting in these settings. So there have been 2 studies, and I'll talk about one here from Tanzania, which was completed by Mia Mattioli, who's also here at Stanford with Ali. And in this setting, Mia took environmental contamination data from Tanzania and combined it with exposure data from children in the United States, because there wasn't relevant data for children in Tanzania. And looking at just 2 pathways, drinking water and hand-mouthing, she found that actually only 3% of their fecal contamination came through drinking water, whereas 97% came through hand-mouthing. So this kind of throws into question like what we've been doing so far, and it doesn't invalidate anything, but it just makes us have a question mark. You know, what if we consider these other pathways? Then what might we see, and how might it look different? So I wanted to look at this question in Bangladesh and collect all of the data right in the same study site. So we needed data on exposure factors, how often are children contacting the environment, transfer efficiencies, contaminant concentrations, and we wanted all this to be from the same place, so we weren't using substitute data from somewhere else, which might result in inaccurate estimates of dosage. So first I'll talk about the exposure factors. And these are the pathways that we were interested in quantifying. To do this, I first did a structured observation of 150 children of average age about 8 months old. And then we conducted 3 video observations over the course of 3 years to attempt to see how children change over time. The observations were 5 to 6 hours long and conducted at the household while the child was awake and not breastfeeding. And they occur between 7 in the morning and 5 p.m. at night. So there may have been contacts, bathing or eating that happened very early in the morning before our observers arrived, or very towards the child's bedtime that we may not have caught. And this is just a matter of field work. It wasn't safe for our enumerators to be out during that time, so we acknowledge that we may have missed some of those sort of high-risk contacts. So we collected a lot of data. We had 323 total observations, and these are about 6 hours long. We have a tremendous amount of video. And how do we extract the data that we're really interested from these videos? Let's say that this is a video clip, and we're looking at the child on the left. We're tracking through her through this whole video. So for this particular clip, we will code using this template, which was developed, a very similar thing was developed with Stanford about 15 years ago. We adapted it for this setting. And we use this template to code that the child was outside, playing, and that her left hand is constantly touching concrete. And nobody else is interacting with this child. Nobody's putting anything else into her mouth, right? And so the result of this data is a very long Excel file, which took me about 5 minutes to load, that gives second by second detail on what this child is doing throughout that observation. So we have both the duration and the timestamp for that information. And we use this data to calculate hourly frequencies of how many times the child's own hand goes in their mouth, how many times they put objects in their mouth, and how many times they touch every single thing. I will say I have extremely diligent staff in Bangladesh that has worked with me on this, and we even double-coded 10% of the videos to check that they had good reliability between codes, right? So we did a lot of quality assurance on this, and I personally went back and I checked every single soil ingestion event, food ingestion event, and contact with water, thinking about these as sort of higher risk events to make sure that they were real events. So this is the result from that data analysis. You can see the age and months on the x-axis and the frequency on the y-axis with different types of contacts in different panels. The different colors are age groups, and the different shapes refer to their mobility, right? Because you might think that there's quite a big difference between children that are crawling or children that are walking and what they're touching and how often. And in fact, neither age, child sex, or location, indoors or outdoors, were significantly related to the frequency that children put their hands in their mouths. Although there was an association with mobility. So transitioning from crawling to walking was associated with a 25 contacts per hour decrease in hand-to-mouth contacts and 100 contacts per hour decrease in object-to-mouth contacts. I also wanted to compare this data to data for children in the United States, where we have a lot more data, and it's been collected around the United States. There was a meta-analysis of this data, which kind of compiled it all together. And I wanted to know, are children in Bangladesh in this rural setting that's quite different than homes in America or kindergartens or playgrounds where the children in the US observed, how similar or different do they look? So here on the x-axis, you can see the percentile. The y-axis is the frequency of these contacts. The solid line represents the US children, and the dotted line represents the children from Bangladesh. And so this graph is object mouthing. So you can see that children in Bangladesh of all ages that we looked at put objects in their mouth much, much more frequently than children in the United States. For hand-mouthing, it's a bit more complicated. When you look at all hand-to-mouth contacts, children in Bangladesh were again higher than children in the United States. But actually we find out that a lot of this can be explained by their contact while they're eating. And in Bangladesh, it's common to eat with your hands. Children eat with their hands, adults eat with their hands. It's just the normal form of eating. And so when you take that out and you compare the non-food related contacts, it looks quite similar to what we see in the United States. I also wanted to look at some high-risk contacts that you don't see at all in the United States, or at least have not been documented, right? Okay, I shouldn't say that you don't see them. I should say haven't been documented in the United States. Maybe a lot of you have young children in your lives and you definitely see them eat dirt. But the frequency has not been published. So instead of attempting it to compare to US children, I compare to children in other low-income settings that we have data on. So the study by Naguri was in Zimbabwe and involved children 3 to 23 months old, just 21 children. And then there was another study in a different part of Bangladesh that involved 216 children. And so you can see here that it's relatively comparable, and that children 6 to 23 months old, approximately 1/4 were observed ingesting soil every day. So this isn't caregiver reported. We're not relying on mothers noticing that their children are ingesting soil. This is from our own video observations. And this might seem high, if you don't have a child, but if you have a child, it might seem quite normal. You know, kids put all sorts of things in their mouths, and in this setting in rural Bangladesh, there is a lot of soil around, right? Your household floor is made out of soil, your courtyard is made out of soil. It's not a front yard full of plush grass or weeds, right? It's just soil. So there's a lot of availability for this to happen. We also wanted to look at ingestion of fecal matter. So the study from Zimbabwe sort of raised a lot of people on edge because children were observed ingesting chicken feces. And I said, is that really that common? You know, we only had 21 children in his study, so I wanted to look at this specifically in Bangladesh. And in our 323 observations, we only saw 4 observations in which a child did, in fact, directly ingest fecal matter. And the same way that soil is much more available in the Bangladeshi setting, fecal matter is also much more available. So I just came back from Bangladesh 2 weeks ago, in fact, and there's this great picture. Just the whole courtyard is different types of poop drying. You know, there's like poop on sticks drying, and then there's poop patties that are drying, and then there's like different sizes of poop patties drying. So, you know, if a mother is busy cooking and a child is just walking around, it's not hard to find some interesting, fun thing to put in your mouth. You know, that said, it wasn't that common. I think there's still the understanding that this isn't a good idea, and in our observations we saw a mother, you know, try to remove fecal matter from the child's mouth. It's not that people think it's okay, it's just children are children and they wander around when they're not supervised. And I should point out here, these mean that no fecal matter ingestion was observed, and then in some cases there was not observation of children of that age group. So moving on from this exposure of how children contact the environment and how often, I wanted to look at transfer efficiencies. So how much of the contamination that is on that green cap is actually going into her mouth, right? It's not all going to come off the plastic, you know. So for things that are directly consumed, such as water, food, and soil, we assume that 100% of that contamination goes into the child's mouth, right? If they're eating the whole bulk of it. But if there's fecal matter on a child's hands or on a ball, then we assume, well, we don't assume. We look at the literature and we say, okay, so, you know, what can we use as parallels to the literature to figure out how much of that E. coli or fecal matter is coming off of that and going into the child? And then I got to learn about things like tongue friction and sucking force of, well, you're sucking on something. And so we looked at the literature and determined that about 66% comes off. And this actually ends up being a really important number, and it was important to do this analysis because it changes the result quite a bit. So now that we have information on exposure, transfer efficiencies, we want to look at the concentration of the contaminant in the environment. So I was really fortunate to work with Amy Pickering here at Stanford and Aisha Erkiman at Berkeley. They led this study. It was in my master's year, and I really just got thrown into hot, sweaty Bangladesh. You know, I'm trying to give you that feeling right now, of hot, sweaty Bangladesh. So you can feel what I felt when I first arrived there. I was really lucky to, you know, do everything from code the survey, to hire the staff, to work with Jeff Scremby to set up the lab. And then I, in fact, lived and managed the lab for about a year. So it was a really great experience, and we processed a lot of environmental samples. So we looked at E. coli at about 10,000 plus environmental samples, and we looked at stored water, pond water, and drinking water from a tube well. We also collected flies from outside the kitchen area. We collected soil from the courtyard where the child last played. We took handwritten samples of children. We also collected food that mothers had prepared to feed to their children, and balls that were given to the household, plastic balls that were rolling around for 24 hours, collected those and sampled those as well. I should mention, again, we were looking at E. coli here. We were using the IDEX most probable number test to enumerate E. coli, and E. coli is not a pathogen. We were not trying to say that we're looking at pathogens here. We were looking at feces. So we're using E. coli as a fecal indicator bacteria. And a caveat here is that E. coli has been found to live naturally in tropical soils and water. So we can't be assured that all of this E. coli is from feces or newly deposited feces, but we're gonna assume here that that is the case. Okay. So here are the results from that study. So on the x-axis, you can see the different types of environmental media, and on the y-axis is the percentage of samples that were contaminated. So almost 100% of soil and ponds were contaminated with some type of fecal matter. That might seem kind of gross. It might seem kind of surprising, but I lived across from a pond and everything happened in that pond. Children swam in that pond, people washed their trucks in their pond, they washed their dishes in that pond. So I am not really surprised that there is high contamination of ponds. Also in rural Bangladesh, there's not great fecal sludge management. So maybe you have a latrine, and maybe that latrine kind of empties directly into the pond behind your house. So, it's not surprising that ponds are very contaminated, and it's also not surprising that soil is very contaminated given the number of animals people have. 97% of families had chickens, right? And 69% of families had cows. And so, as I was saying before, fecal matter is used on a daily basis, and it's deposited by animals on a daily basis. So it's not really surprising that some of this stayed on the ground and got ground into the soil. I'll note here that the units on these are all different, and so when you see the concentration of E. coli in each of these media, you can't directly compare them because the units are different, right? How do we compare a dry gram of soil to a fly, to 2 hands, right? They're also not comparable in terms of children's exposure. Children aren't eating a fly, right? And they're not licking 2 hands in 1 day. So for that, we really need to go back to the exposure data and combine them all together. So now that we have some data on the exposure factors from the structured observation and the video observation in my chapters 1 and 2, we also have data on transfer efficiencies and the contaminant concentrations that I just showed you. And we can put this all together to make a model and estimate dose. And in my dissertation, I estimate both total ingestion of soil and total ingestion of fecal matter. But for now, we'll focus on ingestion of feces. So in this model of fecal ingestion, I included direct ingestion of drinking water. And these are clips directly from our video, so they're a bit hazy, but I just wanted to show you sort of what our video looks like and what the coders were seeing when they were trying to process all this video. We also included direct ingestion of food, direct ingestion of soil, and direct ingestion of fecal matter. In addition to mouthing of objects, and although children put many, many different types of objects in their mouths, all we had to proxy this was this one plastic ball. But we're just assuming that that represents the concentration of contamination on all these different types of objects that children might put in their mouth. We also considered children's contacts with hands, and we looked at this pretty carefully. We wanted to look at children's contacts with their own hands as well as caregivers' hands. And we considered whether these contacts happened while the child was eating or not eating. And that was important because we make different assumptions about recontamination during these periods. So if a child is not eating, then we assume that there's complete recontamination of their hands before they put them back in their mouths, right? And that means that the sequence of events is not important. So even if this child is freshly washed, then they probably will get dirty again before they put their hands in their mouths. Some of you may have your own experience with this. I think one of my friends brought their child today and they said, it was a really rough day, like we just washed her and then dirty right away, before we even had a chance to go through 5 minutes of being clean. So we assume that, when you're not eating, it's really easy to recontaminate yourself and hands are recontaminated before every contact. However, while you're eating, we could see in the video that a kid might have a mango or a potato chip and just carry this thing around, right? Eat it, bite it, okay, keep going, bite it again. But they weren't recontaminating their hand in between that. So even though their hand might have touched their mouth multiple times while they were sort of munching on this mango, we assumed that there was no recontamination of the hands between those contacts. Another thing we wanted to consider when looking at hand mouthing was whether the contact with the hand was directly with the child's inside of their mouth or the side of their mouth. try to get really detailed here. And this was actually inspired by work from Jim Leckie. Their group had done a lot of exposure research on children in California in the Salinas Valley and their exposure to pesticides. And so they had some data that we drew on here. We also drew on their data for the fraction of the hand contacting the mouth in these different types of situations. Okay, so now we have all the data. We have to make the model, right? So the model is per child per day for a single pathway. So let's say this is the child, and we are interested in how much fecal matter they get from putting their hand in their mouth. So first we look at their exposure factor and the distribution, so the frequency that the number of times they put their hand in their mouth over the course of the day. And then we combine it with the distribution for transfer efficiencies, which I covered in the middle part. And we also combine that with the information on contaminant concentrations, right? So how much E. coli or fecal matter is on their hands when they're putting it into their mouths. And we can combine that and get dose. So in this Monte Carlo simulation, in the first iteration, we chose one value from each of these distributions, we multiplied them, and we got dose. And we did this simultaneously for all the different pathways we were interested in. And then we did another iteration, and we chose, again, from these distributions, and combined them to get dose. And then we ran 10,000 of these simulated child days with subtotals from each of the pathways and a total fecal ingestion for that child for the day to get a distribution. We then took a weighted mean of those in order to compare the different pathways. And the weighted mean is based on the total amount of feces that child ingested. So I didn't really want to consider the percentage of ingestion from water when a child ingests 0.1 milligrams, the same as the contribution from soil when a child ingests 10 milligrams, right? Because although we don't have a dose response curve for fecal ingestion and health outcomes, we assume that more is worse. We're just going to make that assumption right now. And so to sort of take a public health perspective to this and think about the kids who are probably more seriously affected, we took a weighted average. And the results are here. So for children of all ages combined, ages 0 to 35 months, the primary pathway was direct ingestion of soil, just crawling around and tasting that mud pie. And that contributed 33% of total fecal matter ingestion. Whereas putting hands in the mouth contributed 27%, foods 17%, mouthing objects 15%, direct ingestion of fecal matter 5%, and fluids 4%. So now I'll show you the results broken out by age group in a slightly different format. So in this format, the x-axis is the different type of environmental media, and that correlates to different colors, whereas the y-axis is the percent of total fecal matter contributed by that pathway. So for children less than 6 months old, the primary pathway of ingestion was mouthing of objects, contributed 14% of their total intake of fecal matter. Whereas for children 6 to 23 months old, the primary pathway was direct ingestion of soil, with some other pathways showing up a bit. For children 12 to 23 months old, food actually contributed about 20%, as did children putting their own hands in their mouth while they weren't eating. For children in the older age group, 24 to 35 months old, the primary pathway was again them putting their own hands in their mouth, but it's a bit more distributed. There's not one that stands out quite as much as for the other age groups. So ingestion of food was also relatively important for them, as was mouthing of objects. So when we put all of these results together, you can see that the primary pathway really differs quite substantially for different age groups. And importantly, the amount also differs quite substantially. So children under 6 months old are only consuming about 0.2 milligrams per day, compared to children 12 to 23 months old, which is 6.6 milligrams per day. And It's kind of hard to say what these values mean, given that we don't have a dose response curve. So I can't tell you that, it's linear, and therefore the kids at the top are facing, a lot more risk in the linear sense. And I can't tell you that it's a threshold, and that the threshold is at 0.1, and therefore they're all at high risk. Or maybe the threshold is at 8 milligrams, and they're all at quite low risk. We don't have that kind of information yet, but I think you can still note that they're pretty substantially different. And we could look at that more in the future. So we then wanted to conduct a sensitivity analysis to figure out which of the model parameters are really influencing that estimate the most. So I broke down the parameters into 3 categories relating to the exposure factors, the transfer efficiency, and the contaminant concentrations. So for children of all ages, saliva extraction efficiency, the one that I said was 66%, that actually turned out to be really influential in the model. Whether you chose it was 80% or 40% changed the ultimate dose a lot, as did the concentration of E. coli in feces. And it's helpful to look at these sensitivity analyses when you think about where should we do some research next, right? Because if these things are changing the model most, maybe you want to put more time and effort into making sure you have those values accurately defined, or at least the variation in those values. So when we break it down by age group, different parameters are sensitive because different pathways are driving their total ingestion, right? So remember these young kids under 6 months, they were mostly getting their ingestion from objects, putting objects in their mouths. So, as you might imagine, the concentration of E. coli on that object was really influential in determining that ultimate dose for them. Similarly, with children 6 to 23 months old, remember about 1/4 of them were ingesting soil on a daily basis. And if we change that from 1/4 to 1/10, right, it changes the dose a lot because we're looking at a population level. So that exposure factor was important, as well as the concentration of fecal matter or E. coli in the soil, as you might imagine. Similarly, for older children, their pathway was driven by their hands, and so the most influential parameter is the amount of E. coli on their hands. So in this setting, it looks like the exposure factors maybe are not as important to accurately define as the contaminant concentrations. And in fact, when I artificially tripled the frequency that children put hands or objects in their mouths, they still were not as influential as the concentration of contamination in the environment. So, in this setting, it looks like, I should say, in this setting with this particular outcome of fecal matter ingestion, it looks like, you might be able to use data from the US that we already have a lot on, because the model result is not that sensitive to what you put in. And that you should put more of your effort into clearly defining what the environmental concentrations are. But that may not be true for other contaminants, right? One reason that the concentration of the contaminant in the environment is very influential is because there's a very wide variation in that. But other contaminants, there might be smaller total concentration, or there might be less variation. And so in those cases, looking at the exposure factors might be more relevant to accurately estimating total dose. So looking at contributions from this work, a primary contribution is that we generated exposure factor data for children in low-income countries. And we showed that the frequency that children put objects and hands in their mouths is substantially higher in Bangladesh than same-age children in the United States. But as Steve likes to remind me, this was a study of one, right? One country. And so it's unclear how this might apply to other low-income settings or low-income countries. Another contribution of this work is that we conducted a comprehensive evaluation of all of these pathways, which helped us identify a pathway that's been historically kind of neglected, which is direct ingestion of soil, or at least the way that soil can contaminate other things like hands and objects in these spaces. And so soil can be contaminated by child and animal feces, as well as fecal sludge from latrines that's not properly disposed of. And most wash interventions focus on drinking water treatment, adult use of latrines, and haven't addressed child or animal feces management as well. And so the contamination of soil maybe doesn't reduce with these types of interventions. And since soil is contributing a lot of the total fecal matter ingested by children, if an intervention isn't really addressing that pathway, you might imagine that it's not as successful as it would hope to be, right, in reducing ingestion of fecal matter and diarrhea or other fecal-oral diseases. Another primary contribution, I think, is that we determined that the relative contribution of fecal intake pathways differs by age groups. And this has implications when you're thinking about your intervention, right? Are you really going to try to focus on kids that are under 6 months old? If so, maybe you would have a different intervention that is focusing on kids that are 6 to 24 months old. It also has some implications on perhaps studies that are already finished, data analysis is done, because it shows that if you had an unbalanced number of children in each of those age groups, your intervention will have different effects and different effect sizes on all of them. And so if you sort of average them all out, that you might miss that your intervention is having an effect on one age group but not another age group as much. Let's see. And I think one thing that I didn't put up here, but I kind of like to think that I tried to take the perspective of the child, you know, and see what the child is seeing. And I think just taking another perspective can be really helpful. And approaching things from a different angle, I think sort of maybe helped elucidate that this ingestion of soil is something that's occurring, something that could be potentially important, right? So like taking the lens of the kid and thinking about what their everyday life looks like. It has a lot of dirt in it. So I was wondering, you know, how often does that dirt go inside of them? In terms of future research, my dissertation suggests several lines of future research. So, well, I explained that, you know, maybe the exposure factors of hand and object mouthing weren't highly influential in this model of fecal ingestion in Bangladesh. It doesn't mean that they aren't relevant in other settings or for other types of outcomes, maybe ingestion of heavy metals. And so, quantifying exposure and fecal dose in other geographic or cultural or economic settings could be useful. It's not clear how like cultural factors of eating with your hand or child rearing practices might vary. So this is a picture of a child in Indonesia where I went on a scouting trip to investigate whether we might do some exposure assessment there. And you can imagine that this child might have very different exposures than a child in Bangladesh, right? They're both sort of technically low income settings, but child rearing practices, I don't think that kid's gonna get out very easily and go around and eat some dirt, you know, without somebody noticing. So I think there could be quite substantial differences, which could result in different exposure factors in these different settings. So before we conclude that, you know, oh, exposure factors in general aren't as relevant as environmental, you know, contamination levels, we should probably look at some other settings first. I think it's also really helpful to look at pathogen survival, infectious dose, and virulence. And when you think back to those pathways, it's easy just to compare them directly, which is sort of what I had you do. I just went across and I said, we're just going to compare all of these pathways as if they are equal. But that may not be true, right? So there's evidence that typhoid, when transmitted through water, has a lower infectious dose than when it's transmitted through food. So pathogens, you know, particularly when we're looking at the outcome of diarrhea and we're focused on pathogens rather than the outcome of environmental enteropathy, looking at fecal matter in general. When we're looking at these pathogens, they might have different survival in these different environmental media because of, you know, temperatures or moisture. They might have different infectious doses for when they get into the body, and they might have different virulence because they've been hanging out in food, you know, and they're like ready to go, or they've been hanging out on a plastic ball, and maybe their virulence has diminished in that. So I think there's some data we can use to look at this, but I'll tell you, writing this part of my discussion section, I didn't find a lot. So I think there's some more work that can be done in this area to understand how pathogens and the environmental media they're in interact, to sort of, again, better understand what these results mean. Another area of future research is developing and testing interventions both to reduce fecal contamination in the soil and to keep kids from ingesting soil. So, as Steve and Jenna were mentioning, I kind of like to get involved in everything. So even though I had, a dissertation presentation coming up, I submitted a proposal yesterday with my Bangladeshi colleagues to USAID on a project of looking at how to reduce children's exposure to poultry feces, both directly and that might have contaminated the soil. So I think that there's a lot of potential here, and I would say that I don't think there's any crazy innovative solutions. I think a lot of it is sort of adopting maybe things that we've seen work in other places. So we'll see how that work goes. But I think these are really fruitful areas for WASH to consider in going forward and in interpreting the results of this dissertation. So I'm happy to take any questions you might have.
Anybody? Questions? Yeah.
Do you offer some ideas on why object mounting is higher in Bangladesh than in the US?
Great question. Pacifiers. So pacifiers may reduce object mouthing because they're constantly stuck in a kid's mouth, so the frequency would be lower, although mouthing of that particular object, the pacifier, would be longer in duration. There's been one study to look at this, and it was in Taiwan, and they kind of had conflicting results. But pacifiers might be one. I know my brother, in fact, had a elastic strap on his child's pacifier, so it would just stick right in there. It would not come out, which I kind of thought was a brilliant idea. There's also just other ideas about maybe supervision that might be around, or other stimulation activities. Children here are maybe on their screens a lot more, doing something like that. Of course, that was not when these studies were conducted. So yeah, I haven't thought more specifically about that. Although I guess, I don't know how this would exactly relate, but there's a lot of people around in a Bangladeshi compound, and so there's a lot of people to interact with and play with and things to put in your mouth, whereas it might be sort of less interaction and kind of more solitary play here. So?
I was just curious about how you coded or what you did in thinking about breastfeeding or bottle feeding infants, I guess below the age of 1, because I think that's what it's relevant.
So we did not observe breastfeeding because of privacy reasons, and the child may have also done other things while we were not observing, because we only started observing again when the child sort of reappeared in the public space. There have been studies that show that, mothers' breasts are not completely clean, especially when mothers are bathing in contaminated pond water in these settings. And so we can assume that they're not completely clean, but I didn't have enough data to sort of quantify that. When I looked at food intake in this, we used a study also from Bangladesh. We didn't quantify food ingestion just based on my observations. We used a much more detailed study of food ingestion from Bangladesh and calculated the dry grams that children consumed, and then used the dry grams, the E. coli and dry grams of food from our own study. So yeah, we didn't look specifically at breastfeeding for lack of data.
Yeah, so why, for your next project, are you focusing on poultry contamination? Versus like other animals or people?
Oh, okay. So Campylobacter, which is carried by poultry, also other animals, but primarily by poultry, has arisen in some studies to be a highly relevant factor for diarrheal illness. And so USA put out a call, well, Gates put out a call to say, let's figure out more about Campylobacter and Campylobacter transmission. And so, I'm hoping to work with that team more closely on observations of children interacting with chicken or chicken feces. At the same time, USA just sort of jumped ahead and we're like, oh, let's just figure out how we can keep kids away from poultry feces. So thinking about animal feces interactions with that way. So partly it's like a funding call. issue, but partly it's the increasing amount of evidence that shows that Campylobacter is a pathogen of primary concern when thinking about diarrhea in young children. Yes,
So in a
ma'am?
refugee camp, what would you expect to be different? Because there you have a high concentration of people in a small area, relatively speaking.
Well, Bangladesh, you also have a high concentration of people in a very small area, let me tell you that. Bangladesh is the size of Iowa, and it has half of the US population. So it is extremely dense in Bangladesh. In refugee settings, I think it probably depends where you are. I think refugee camps are often on very marginal land. So I would similarly expect like a high concentration of soil to be present. I think actually a primary thing that might be different is just child raising practices. So in Bangladesh, I don't often see mothers sort of carrying children on their back or keeping them just sort of right on their body, because a lot of life happens just in the household courtyard, and so the child's not going to go very far. So you don't need to strap them to your back. Whereas I think in other cultures, you know, and refugee camps have many different types of cultures in them, but I think in other cultures where a child is sort of tied onto the mother and prevented from moving around as much, there might be less contact with soil, fecal matter, and even just other objects to put in your mouths. The question of soil contamination is interesting in a refugee setting. There's often very short-term solutions to managing fecal waste and human waste in refugee camps. And refugee camps can last, you know, mean age right now for refugee camp is 17 years. So it's not like, you know, you just go and the soil is clean and then you leave. It's like people are living there continuously, and that type of similar type of contamination might build up. The difference might be contamination from animals. I'm not sure about the presence of animals in refugee camps, if they're allowed or anything like that, but that might be a big difference. Oh, hands everywhere. Ben.
Thanks. So you talked a little about this in your conclusion, but I had a question about the uses of your sensitivity analysis, which was that you spoke mostly about it in terms of identifying important research, like narrow estimates and that kind of thing, but I was wondering if it also, like certain parameters are things that are basically the environment that are hard to intervene on, and then some of them presumably very closely related to interventions, and so I was just curious if there's like definitive lessons from that. Certain there are parameters that are sensitive and that are also things that can be easily intervened on, or is that not legitimate to?
That is a great question. So I gave a practice presentation to my colleagues in Bangladesh, and the first question was like, so Laura, what do we do? You know, it's general household cleanliness sort of looks to be what might help children a lot, because you would generally reduce fecal contamination across the environment. So, there's also work from Audrey Lynn that shows that households that just generally seem cleaner, they have some objective measures, but you can also go there and just see that this household is cleaner. Children have lower rates of environmental enteropathy. So I think general household cleanliness, we can hope that improved flooring might help households clean up easier. So I think some of it you might be able to encourage better household cleanliness, but I think it's really hard because you live with animals and you need those animals for your protein and for your income. And so there's not any way to just like make those animals go away. So I think there's a lot of thinking to be done there. Yeah. Stephen, do you have a question?
Is along those lines, but beyond household cleanliness, do you have other intervention ideas on how to reduce soil intake, ingestion?
Well, so I'm working with Earth Enable in Rwanda. They have a flooring which is it's sort of like a varnish. And I should say Earth Enable was started by students here in Jim Patel's class in Design for Extreme Affordability, and they're sort of rolling this out across Rwanda to put this varnish on floors to reduce access to parasites that live in floors and ingestion of soil. So that could be one possibility. Although I should say that children spend a lot of time outside in these communities. So in Bangladesh, children spend approximately half of their time outside, right? It's not like Americans where we spend 90% of our time inside, and then go into our cars and then go into another building. It's like children are very much outside because, their house is small and dark and it's just more fun to be outside. So I'm not sure that sort of indoor flooring solutions are going to help that much. But in terms of, it might be something similar to keeping children away from poultry feces. It's like keeping, using a gate or something to keep children on the veranda or in the house. Not all the time. It's important for children to explore, but sometimes, and having that inside space be a finished floor, so they would have less access. Yeah.
I was wondering, with your experimentation with the recording of the exposure and glucose, it seems like hundreds upon hundreds of hours of video that are coded down to the second.
Sure is.
Have you thought about if to make like a larger claim about this in other settings, ways of improving the efficiency of how to go about that analysis?
Yeah, so one relevant part is that, we're uncertain how much the exposure factors matter. So I think we still need some more studies to assess, if we need to do exposure studies in every single location we go to, or if we can take one that seems from a relevant setting. Maybe we don't have to do exposure assessment at all. But secondarily, it looks like our structured observations were able to capture this, the frequency data pretty well. Not the hand contact data, but the frequency of mouthing. And because we assumed that, at least for this model, we assumed that sequence is not important, and we're really just interested in the frequency of hand and object mouthing, or soil ingestion, or that we can capture that on with structured observation easily. And so that takes 3 times less than video. Because video, you record, and then you watch it, and you record the right hand, and then you watch it, and then you record the left hand, and then you have to do 10% more, and then you have to check it again. So structured observation can really collapse that time, because you just do it once. And you can use that same sort of palette that I showed you. So my friend Julia, computer science, master's at Stanford, helped make this appropriate for a tablet. So you could just take the tablet and still have this very convenient palette to just record right there. So I think, both of those could help. Is using structured observation, and then in the future sort of determining if you need a locally specific exposure assessment at all. Sorry, not exposure assessment, exposure factor assessment at all. Yeah.
Has anybody ever figured out which children actually get diarrhea? Of those you followed, how many children actually got diarrhea, do you know?
So we have a lot of diarrheal data from the children in watch benefits, but it's not time correlated with our observations. And honestly, even if it were, we don't have enough children to make any causal inference from. So, any last question? Yeah? Okay.
If you were to repeat chapter 1 with, say, like adolescence, what do you think you would find in terms of just mouthing and those sorts of events?
Oh, interesting. In Bangladesh?
Yeah, or anywhere, but particularly in Bangladesh. Yeah.
Particularly, I don't know. I don't hang out with adolescents in Bangladesh. I just like hang out with tiny little school kids, or like kids that can't talk to me yet. I think that is a great question. Actually, even in the U.S., there's very little data on children, 6 to 11, or in older age groups, and partly it's because we're not quite as worried about their health outcomes, right? So young children, we're really worried about them because in the first 1,000 days of life, that's when insults to your health really can have much longer term impacts than adolescent kids. So I think kind of in general they're quite neglected, but I'm also quite not as concerned about them. So yeah. Okay, thank everyone for coming. Leave the cookies here for my mother to take back, and there is a reception at 5 by the sunken tree in the quad. And I hope to see you there. Okay. Okay, wait, I feel terrible. Oh my gosh, I feel terrible. All right, I was too caught up in questions. Like, okay, skip all these slides. All right, so, oh my gosh, I feel so bad. Okay, I'm supposed to do some acknowledgements. All right, so a lot of people paid for my research, thanks to them. A lot of people helped me with the research, thanks to them. Okay, but the really important part is the people who like mostly just left because I was like so, I don't know, caught up in myself. All right, so thank you to the poop group who really took me in when I got here at Stanford. Yeah, it's been really great to say I'm a poop group member. Thank you to the Luby Lab. I don't know what I would do without you guys. Really been there at every turn. I want to thank all my really great staff in Bangladesh and colleagues and friends who, you know, living in Bangladesh is not easy, but I really love going back because I have so many great friends there. And thank you to my family, my dad who is never satisfied, and therefore now I have almost a PhD, we will see. And thank you to some really close friends who I could not do without, for sure. Yeah, I really appreciate you guys. And thank you to my house. I think all of you at Ithaca have made me the happiest grad student that exists. It's so nice to come home every day to your happy smiles and conversation and dinner and hugs and support, and it's been really, really, really fulfilling to live at home. And to all those people I can even put on this slide because, as Jenna said, I'm a communitarian and I just make a lot of friends. So I'm just really thankful for all the communities I've been able to be part of. And thanks for staying extra for this acknowledgement section. Pretty good.